we move to next chapter of this book, so the doing math with Python. So we continue to learn the chapter 6, drawing geometry shapes, and we already draw the shapes in first subchapter. Now that we move to the second part is drawing fractal. So we will have two the sessions to make this. But before that is I put our link here. So one link is for the generic fractal. Another is for next video is when we talk about the Barnsley form. Is going to that the Wikipedia. So fractal in mathematical definition is geometry, shape, content, detail, structure at arbitrarily small scales. Usually have a fractal dimension strictly existing the topological dimension. So you can see here is some famous fractal, especially this one you may see a lot of times from many other sources. It's called this Mandelbrot set. So that is also have our kind of the animation in this Wikipedia. So when you keep zooming in this boundary of this Mandelbrot set, you can see it's from the tiny distance wide. Gradually, they will see it's still the same, the simple one like this. So that is the fractal. So it's a complex geometry pattern or shape arising out of the surprisingly simple mathematical formats. So to make that is we should learn the two major things. Is one is we should know how to draw our shape, which we practice in the previously subchapter already. Secondly is we need to make the shape doing the transformation. So transformation either is the move or is the rotate. So those are the transformations. So actually it's talking about transformation will be more interesting is when you start to design the 3D shape for now is the often used on the 3D printing. So if you have interest, you can go to my channel. I have several videos talking about using the OpenSCAD to make the 3D design. It's using this software or the tools so that you can have the 3-dimension the shape and during that design. It's a lot of discussion about the transformation. So it's a translate means move, or the rotate means the rotations, and also you have the transformation like the scale or the resize. So, but if we making our basic step of a little bit to prepare the fractal, we will need to know the how you can move our points. We use the formal term is transform a point in a plane. So let's assume is we just have our two-dimension XY plane. So this video is we will talk about how you can move or how you can have the basic idea to transform point in this XY plane. So as our example, the starting point is originally this point is in one coordinate pair is P is the point with x axis is x, y axis is the value is y. And what we are going to do, the transformation is we want to move it to P x plus 1, y plus 1. So that's we go to the Q. So even you see this like a rectangle, but actually this is our square. So from P to Q, that means is P is x dimension is add our positive 1, y dimension is the same. So both have our positive 1 added. Then this the second point go to Q, and again you can do this third point go to R. So with the repeat this one. So fractal is the once you know the transformation with one step, just keep repeating that. And either is you will have the reshape and also the resize, or that means the scale. So and then this you can make those simple. Nowadays our beginning point is a single, starting is just 1 point. That is a 0-dimension shape, and you move that. So consider this is our one dimension that will be a line. When you move this line, you may get our shape of our face. So, or you can keep this line as a discrete line, so just a multiple line. And if this original shape is our face or our space, then you will get move that to another direction. Then you will get our these bodies, 3D bodies. So those are the transformation depending on the where and how you transform. So all the transformation in the plane, or these are two-dimension plane, or in the three-dimension space can be translated into the mathematical way. So which means it's a fractal. Has a very strict the definition by any the simple the shape first, then through the formula of the transformation, you can get that those the to be the shape. So which means we call that this transformation as the rule. So from here is this is the rule is if we say P is P1, Q is P2, R is P3, so then P2 is their coordinate is both is +1 from P1, and the P3 is both coordinates value is +1 from P2. So when you repeat from P1 2 times, you go to R, point R. So that is the rule. And this transformation, we can do the some little bit rule is the difference. We see is if we have two rules with a random the step. First is rule 1 is like is x is moving to the right with 1 unit, but y is moving to the lower with 1 unit. And then the rule 2 is x you move to the same direction right with 1 unit, but y is now is moved to upper 1 unit. So y is can be up and down, but x is keep moving to the right. So this is our new rules. And well, if we do that is and if we put this picking up these two rules in the random way, then we don't have a way to forecast which is going up or going down. That is the random happened. But when we have the statistic there is a volume, you can starting to build the pattern. So this pattern will be looks like here. So if we have 100 iterations, you see here is maybe first if we from the 1 then first several this random is just go up and then go down, up and down, up and down. So that pattern, when you run this 100 iteration in another time, you get different pattern. So but when we have that is bigger, so you may get the kind of those the different pattern. We call this path as a zigzag path. So that is a way so can help us to practice the basic method or approach to build the fractal. So first is define your original shape. Now we just starting from a point. Secondly is define the rule for transformation. Third is just repeat at whatever times you want for this iteration. So when we keep practice these 3 steps and replace our original shape and replace the rule, and then this assign the different iteration volume, then you can get the different fractal. We will practice several fractals even in the programming. The challenges parts with such kind of the rules, the implementation. So last video, this video is we built this zigzag, these lines to have our initial idea. So let's starting from the scratch is 0602 is 1. So we call that is the zigzag, the trace or path, zigzag path. So it's like this way. So let's see how we can build that. First is we learn this random element from a list. We have learned the approach of a random. One is just is random is random. So let's use the terminal to do that. So if I put here is I import random, and if I make is random dot random, so without any input is I will get our floating number between 0 and 1. So if I want to get our floating number between the 0 and 10, so just I can make that 10 times, then you get this 1. And like is when we make a dice, the rolling, so we need have our this integer. So that is the rand int. But you cannot make that empty because you must give our argument is you want is int is from 0, 1. Then they just give you the random is either 0 or 1. Or is you see is I want is from 1 to 6. Then you get this 6 sided the dice. So every time you just get this 1. So retrieve keep extending from this. This looks like when you look at this, you can see what's this like. It's like our range 1.6, right? So range 1.6 means is we have our integer. By default, range is assume is the integer, so it's 1, 2, 3, 4, 5, 6, 6 number, and then this every time when you do the rand int, you are picking up from these 6 the numbers. But we still use, we specifically define rand int is our integer rand. But if we have some the non-integer or we have some the string, for example. So if I have s is the string, so a, b, c. So I want this every time is I just wanted to have a random of this list. So either A or B or C, because I may have checking the statement to check is if it's equal to B, then I do something. Then here is we have our random dot choice. So that is another, we will use this in our the next program. So when you put that in the choice, you get that. So just the whatever in this choice coming from the list. But if we see is we have a range 1, 6. So that is our actually is this range. So if I put this S, you can see you can also use random choice to check from a range. So that is looks like it's can overwrite or replace this rand int. So that is depending on which you are going to use. If you just use this to do the random from our integer list or range, then you can do the like this way, use random int, because one the specific difference is if you define a range, is that this range is from 1 to 6 continuously. So you cannot say is I want 1, 2 and skip 3. But if you define our list, so then this I can see is 1, 2, and just I want is 6. Then this when you do this random, they just choose this from your this 3 number. So that is the least the advantage for you to make this the more flexibility. And come to us, this sample is you consider we have 2 rules. We just wanted to see is every time we randomly pick up rule 1 or rule 2. So if we go to the rule 1, then is we do the transformation type 1, means minus 1 from y. If we go to the rule 2, I will put addition 1 from y. So that is the random. So I will do this transformation as a list. You can see here we define that as a list, and when we do this random dot choice, I can go to either one. Then when we return our either ones, this as the list. Then I assign this to t. Then I will use this t replaced by this transformation name. Then send this argument to this transformation function. So that is the smart ways from the author to pick up which one. So if you don't use this way, you can also use I have a random. Maybe I just have a random choice or random int is from 1, 2. And if it's 1, then you call this transformation 1. If it's 2, you call the transformation 2. So that is another way. But here is more simpler. So let's use this way and try to get our new idea is to use the random. So now let's start into our code. So the purpose. So the zigzag path. So then this, we put our header. So we will have the random definitely. So we will have a random, and later on we will need to draw our the shape. So we will import this mat.py. We mentioned this. You can also use from matplotlib import pyplot as plt. So that is the same, just a different describe. So first is let's run our primary. So we set, as I mentioned, is if you want to draw the fractal, you have 3 steps. From my understanding, is one is to set your original the shape, give those definitions. Secondly is define the transformation. Third is repeat. So first is our initial point. So because one point is our shape already. So P is our original point is 1, 1. So that is the X and Y. And then this we ask a user to give us those iterations, so the numbers of the repeat. So this number will be our int. So input, enter the number of iterations. And then this we will build this trajectory. So trajectory is we have this function, and this function will have this transformation rules to be set. So trajectory is we just make a list. The purpose is we should have our list of x, the xl, and the list of y. And now is we have this tuple, and every new point will have another tuple, and this build trajectory is just trying to put all the new point is divided by x and y and put into our to list. So that is our build trajectory, this purpose. So x and y. So here is we can get the multiple the result or return from a function. So we use this comma separate the two different the variable. And then if you have x and y, you need to ensure is your return value is also x and y. So that should be matched each other. So we build our trajectory with p. So p is our this original point, and then the n is our new point, the numbers of the this iteration. So let's make this def build trajectory with p and n. So we have that is then let's do this once we have our xy. So we will have our list, two list return list. Then we do the plotting. So plotting is quite easy. So just plot x and y. Even we don't need this label because it's label just xy is not necessary. So we just show that. But for now, we don't have those x and y. So let's see. So we need to return x, y. So let's just try to see. So I have a 10. And then this return x is not defined. So we need to define what. So x is should be a list. Now we have this x has nothing. So the list is p. P is our point. Is the we use this 0 is the first element. Y is p 1. So now we have a list. So let's see. So whatever I give are 1. So I can't have this. It should coming from 1, 1. So but we don't have our point yet. So let's continue make. So if I put this for I in range n. So if I have n, so x dot append is the p 0. So we will get a new p, and y is append p 1. So what we have that is we should have this p equal to, let's see, so I. So if I just make a dummy program for now, so I have 10 points. So you can see here is when first is I is 1 and the last is I is 9. So every part, I will run the for loop is I have a new point push into this list, and I return this list back. So now we already have our base of the program. What we will do is we need to start to replace this p to this result by the random transformation. So we should define the p is our transform. So transform based on the xy is either go up or down. So let's do this transform. So def transform. Transform is we just send the p as the arguments. So here we can see p is transform p based on the original the p. So let's see. So if I put here is just if I go to p. So xy is from this p0 and p1. So if I put that is x is t is p0 plus 1, and y is p1 plus 2. So maybe I put this is also I need to return x and y because I ask is our p. So xy is this one. So I sent this P, so let's see. So whether it's running okay. So 10 points. So you can go this even still like this direction, but the ratio is a difference. Now is Y is every time is increased 2 units. So that means is we send a P. P has X and Y, and we return a P. So it's also our X and Y. So you can you can also put this as let's see. So P is a transform. So if I say P is X Y, now is I just return P. So whether it's still same. So same. So then is we can repackage the point here. Then we return just 1 point. And then now is we know is whenever we define our transformation here, it will be return back to our build trajectory and read that on every looping in the for loop. And then this back to the main program to make the plotting. Then this starting to apply our second step is what our transformation rule. So we have two rules we can define. So def is transformation 1. We need to read a P. So this is easier. So we have this P. We resolve that X and Y. P0. And then this what directly we return. So we can see here is P is P X plus 1, Y minus 1. And then we return P. So let's just return the single point. So that means is we have the 1 is the go to lower 1, and the 2 is we can see is go to the upper 1 unit. Then we have this 2 transformation. Then we can starting to practice our random choice method to do that. Is we have this transformation. So transformation rules. Transformations equal to our list. So when we define our list, then we can use choice to make a random the selection. So T is the random dot choice from the transformations. Then I can keep getting this the different ways, different transformation from every time I call T transform, and every time means is we have this for loop. We will call that n times, and then we have a T. So what we will transfer to the different transformation, we will use this T. So xy is we just make, because we send the T, so P. So you can see here. Then let's save. And now when we have a T is replaced by this one, and we will come into either here. Then we have those first code this, then code this, then code either these two. So we have 3 levels code. So let me save. So Control C. So let me save. Oh. Let me try to run. Okay. So just let me run 10 times. Okay, you can see here is it's down, up, up, keep upping. But here is from 2 to 3, and then this is already 3, go to 3. So and then this up, and let's run 100 times. Why is go to always the up? So if they don't have that, we should have a similar like this way. So it's starting from the 0. So let's see what's the difference we have. So we got this P0, P1, and here is X is fine, and here is just I think is that they have the some different is that they keep the up. So let's run this more times. Oh, it's like our lines. So append, transform. This one is same. Starting from this, and we do this Pn, return x and y. Build. Print x, y. So let's run this just 10 times to see. So I go to 1, 2, 3 is fine, and 1, 0, 1, 2. So this looks like the y is keep increase. So that is not what I think is 0 is increase, and here is increase 5, decrease 1. So increase 3. So that is not correct. So let's see. So we should have some the maybe so we have some reinitialization. So yeah. So here I have wrong. So both we use the P0. So we should use the X because next it's using the X as the earliest time the values. So let's see. So now I have a 10. Oh, that is good. So it should be changed by based on X, based on Y. So let's cancel this this debug. So let's see if I want to have 100. Yeah, I will get this one. So every time you draw this, you will get different the patterns. So because it's a zigzag with the random. So let's see the 100,000. So yeah, you get similar here. So let me make that even 100 times. Let's just wait. Is oh yeah, is oh, looks like you can find is some trend is decrease is more than increase. But if I run that another time, it can be last time is more than minus 2,000. Now it's minus 1,500, and this up to this the bigger than the one minus 1,000. So this is really random, and you can find this if you keep zooming that. So what's this zigzag means is if you keep zooming that is you can see the same similar pattern because they are keep using this random way. So and you keep drawing that. So that is the fractals looks like is whenever you can keep drawing the zooming, they will give you the more detail, the ways, and every detail, the way still show the same, the standard or same transformation rules that you are using in the larger these pictures. So I think is I cannot I come back to here. So that is our back. So that is the way. Is I hope is you follow this the basic example to make our the line using line to do the up and down transformation to perform the zigzag path. And then this we stays as our prepared knowledge. Next the video is we will do this Barnsley fern. This Barnsley fern is very famous, and also I would like that you can read from the Wikipedia to get a little information about the history and how to construct with the the detail on the mathematical way. So I also put this Wikipedia link here, so you can directly go to the mind map to click and go. So let's see you in the next video. Then we analysis what's the transformation rules and the practice. That's a 3-step fractal drawing activity. So see you in the next video. Bye for now.